Part A. Find the number of different arrangements of the 9 letters in the word activated. Okay, let's look at the repetitions. We have 2 A's, 2 T's, and then nothing else is repeated. Okay, so we will have arrangements 9 factorial upon the repetitions, which is 2 factorial into 2 factorial, which gives 90720. Part B. Find the number of different arrangements of the 9 letters in the word activated in which there are at least 5 letters between 2 A's. Okay, so A, 5 letters A, and then this is a total of 7, and then we'll have 2 outside of this group. Or we could have A, then 6 letters in between, and A here, and then 1 outside somewhere. Or we could have A and then 7 inside and then A here. Okay, now we're going to write arrangements for all of these and then add them together. Okay, so we have 2 A's at 2 spots, so that's 2 factorial times. Now we have 5 values here, 5 spots here, and 2 spots here. And in these spots, we could have 7 remaining alphabets. So we'll have 7 factorial arrangements for all of these. Okay. Also, this is a group. So we could have this group and then these two, or this alphabet, the group, and then another alphabet, or alphabet, alphabet, and then this group. So we times it with 3 as well. So we have 2 factorial into 7 factorial into 3 divided by repetitions, which is 2 factorial into 2 factorial. This gives 7560. Now we're going to do the same for this. So we have A and A at 2 slots, that's 2 factorial into, now we'll have 7 possible alphabets on these 7 slots, that's 7 factorial. And this is supposed to be a group. So we can have the group and 1 alphabet, or an alphabet and the group. So we times it with 2 and divided by the repetitions, this gives 5040. Plus, for this one, we have 2 factorial, then 7 factorial in between, and divided by the repetitions, which is plus 2520. So all of these added together, all 3 of these added give us 15120. Okay. Part C. 5 letters are selected at random from the 9 letters in the word activated. So selection means combinations. Find the probability that the selection does not contain more T's than A. Now, since this is a question on probability and combinations, what we do now is the 2 A's count as 2 different A's and the 2 T's count as 2 different T's. And apart from that, we have C and I, V and E and D. Okay, so it says that the selection does not contain more T's than A's. So first case we'll take which does not have A's or T's. So no A and no T. So now we have 5 of these and 5 slots. So that's just going to be 5C5, which is 1. Next, we can take 2 A's, so A and then a single T, because it says that it should not contain more T's. So this is according to the requirement. There's 1 T and 2 A's. So this would be 2C2 from 2A's, and these are 2, so 2C2. This would be 2C1 because there are two available T's out of which we took one. So into 2C1. And then we have five more alphabets for these two slots, so 5C2, which gives us a 20. Okay. Next, we can take two A's and two T's will also work because it says that T's cannot be more, but T's can be same. So we'll have 2C2 for the two A's, 2C2 for the two T's, and 5C1 for five alphabets that could be selected for this one spot. This gives 5. Okay. Then we can use A and no T at all. So for A, it's going to be 2C1 because we have two available A's, 2C1 times 5C4. Five available alphabets for these four spots. That gives us a 10. Then we can take two A's and no T at all. So again, 2C2 times 5C3, which gives us a 10. And we can also take a single A, a single T, and others. So we have 2C1 for the single A times 2C1 for the single T, and then 5C3, which is a 40. So we get 86. Okay, now we need the probability. Probability is favorable outcomes, which is 86, divided by total outcomes. Total outcomes would be we have 9 of these and 5 spaces, so 9C5 selections. So 86 upon whatever is 9C5, that's 126. Simplify 86 upon 126 and we get 43 upon 63, which is the final answer.